Okay, in this last section of building the unit circle, we actually already have it built. So now we are going to evaluate for sine, cosine, and tangent ratios using the unit circle. So we have the entire unit circle here in the bottom right corner that we can reference, and we're just going to do a quick review. Remember, our x value represents cosine of the angle. Our y value is going to represent sine of the angle, and the ratio of y over x, or sine over cosine, is going to give us tangent of the given angle. Don't forget the reciprocals. So secant is the reciprocal of cosine. So secant of x will be 1 over cosine, or 1 divided by your x coordinate. Cosecant, CSC, is the reciprocal of sine. So that would be 1 divided by sine, or 1 divided by the y coordinate. And cotangent is the reciprocal of tangent. It's also its cofunction. So we can list this one as cosine divided by sine, or the x coordinate divided by the y coordinate. And we're going to see some patterns for these as we go through our examples as well. And we will list those as other reference points to help us kind of memorize so we don't have as much work to do when we need to evaluate values around the unit circle. So our first example, sine of 30 degrees. Okay, so it has given it to me in degrees. That's the easy part. I need to remember that sine is the y coordinate. So this is really asking you, what is the y coordinate at 30 degrees? So when I look at my y coordinate at 30 degrees, my value is 1/2. So sine of 30 degrees is 1/2. Yes, it is that simple. Okay. Number 11, we're doing the odd ones first, is tangent of 4 pi over 3. So remember, tangent is going to be the y coordinate divided by the x, or the sine value divided by the cosine. And I want to look at 4 pi over 3. So 4 pi over 3 is greater than 3 pi over 3, so I know I'm going to be in quadrant 3. So 4 pi over 3 is down here at 240 degrees, and I need to use these two values, negative 1/2 for the x coordinate and negative root 3 over 2 for the y coordinate. Okay, so I'm going to set up the ratio for tangent, which would be negative root 3 over 2 divided by negative 1/2. Okay, since both fractions have the same denominator, if I'm dividing by 2 in both, I can reduce those, which will give me negative square root 3 divided by negative 1, which works out to be positive square root of 3. So the tangent ratio at 4 pi over 3 is positive square root 3. For secant, number 13, we need to remember that is the reciprocal of which one? So secant is the reciprocal of cosine. So what I really want to do is determine what is cosine of pi over 3, and then write its reciprocal or flip it to get secant of that value. So cosine is the x coordinate. So I'm going to go to pi over 3, which is in quadrant 1. That would be 60 degrees. And I need the x coordinate for cosine. So cosine of pi over 3 is 1/2. Therefore, its reciprocal, if I flip that upside down, secant of pi over 3 would be 2 over 1, or just 2. And last but not least, for our odd examples, we are doing cotangent of pi over 2. Pi over 2 is the same as 90 degrees, so we are up here at our quadrantal angle. And cotangent you can remember as cosine over sine, or the x coordinate divided by the y coordinate. So x coordinate of pi over 2 is 0, the y coordinate is 1, so 0 divided by anything would just give me 0. So the value of cotangent at pi over 2 is 0. Okay, our next examples are the evens, and we're going to start with cosine of pi over 4. Remember, cosine is just the x coordinate. So at pi over 4, which is 45 degrees, what is my x coordinate? It is the square root of 2 over 2. Done. Example 12 asks for tangent of 150 degrees. Remember, tangent is sine divided by cosine, or the y-coordinate divided by the x-coordinate. So at 150 degrees, we are at 5 pi over 6. We are going to take our y-coordinate, which is 1/2, and divide that by our x-coordinate, which is negative square root 3 over 2. And again, each of these fractions have the same denominator, so if I divide by 2 in both of them, those can eliminate. And tangent of 150 works out to be -1 divided by the square root of 3. So in this case, you do have to rationalize. Once we do this once and we see the pattern, you won't have to worry about rationalizing again. You'll just remember what they work out to be. So to rationalize, I need to multiply by the square root of 3 and numerator and denominator, and then simplify. So -1 times the square root of 3 gives me negative square root of 3. And the square root of 3 multiplied by the square root of 3 is the square root of 9, which is just 3. So tangent of 150 degrees is negative square root 3 over 3. Okay, our next example is cosecant of pi over 6. Remember, cosecant is the reciprocal of sine. So we first need to look at the value of sine of pi over 6. And we're looking at our y-coordinate. So at pi over 6, we only need our y-coordinate, which is positive 1/2. So if sine of pi over 6 is 1/2, its reciprocal for cosecant would just have a value of positive 2. And our last example for these is secant of 225 degrees. That is in quadrant 4, which is 5 pi over 4. And we need to remember that secant is the reciprocal of cosine. So if I find the x-coordinate of 225 degrees, we have negative square root 2 divided by 2. And I'm going to need to rationalize that as well so I can get the reciprocal. Or excuse me, so I can get the value of secant, which would be the reciprocal. So if I flip that upside down, secant would be -2 over the square root of 2. When we rationalize, we have to multiply square root 2 over square root of 2, which gives us -2 times the square root of 2 over the square root of 4, which is 2, and that reduces to just give me negative square root of 2. Okay, so when we rationalize the square root of 3, 1 over square root of 3 becomes square root 3 over 3. When we rationalize the square root of 2 over 2, when we do its reciprocal, we will just get a square root of 2 as an answer.